Hello guys, my name is Akibale Stephen Bugadam, and we are actually going to look at sequence and series. So someone may ask me, that what is a sequence? Don't worry, there are a lot of sequences with their unique definitions. So in this your syllabus, that is the YIC SHS syllabus, we are going to deal with an AP and a GP. So quickly take a look at the AP, and then we'll solve problems pertaining to the AP. Then next time you follow my next video for the GP and then the combined one. So let's look at an AP. What is an AP? What is an AP? That is arithmetic progression. Arithmetic progression. So what is an arithmetic progression? It is a sequence or a progression whose proceeding, take note of this, whose proceeding term exceeds or surpasses or exceeds its preceding term, by a constant. By a constant. By a constant. But there can be a case whereby the sequence will be decreasing. So what do we say about that one too? We can say it is a sequence whose proceeding term is less than the preceding term by a particular constant. So these two definitions can be combined to give you this. It is a sequence whose proceeding term is the sum of the preceding term and a constant. So we know as well that integers will take care of that, whether a negative or a positive constant. That one is now the matter of the numbers. So that's where you know whether it will decrease or increase. So let's move on. A typical example of those sequences is the set of even numbers. The set of even numbers. That's the set of even numbers is the typical example. That is 2, 4, 6, 8, and dot 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 dot. So you can see that the set of even numbers is a typical example of an AP. That is, this 4 surpasses this 2 by 2. This 6 surpasses this 4 by 2. And this 8 surpasses this 6 by 2. So, generally, when you are given a sequence whose difference, in which the difference between two consecutive terms is a constant, then we say that sequence is arithmetic. Are you getting the different definitions I'm giving? I gave a definition earlier on, and this is another different one. This a different one again. So if there are differences, if the difference between two consecutive terms in a sequence is constant, then we say that sequence is an arithmetic sequence. let's move on. So how do we obtain, like if I want this first term, second term, third term, fourth term, like if I want the 20th term, how will I get the 20th term? We actually, let's assume if you've learnt it already, let's say you know the formula already. We are not going to quote it down here, but we are rather going to prove it. So how are we going to get the 20th term? So what do we do now? Say this is the first term, and then a constant was added to give you the second term, another constant, that same constant, third term, in that order. So let's say, let A be our first term. So if A is our first term, then we add a constant, whether a negative, a positive, it should be the difference between two consecutive terms should give you that constant. So we'll have A plus that constant in such a way that when I take A plus that constant minus the first term, which is A, I should get that constant, D. So in that order, I'll have A plus D, this one, then adding the constant to it. Then I'll have 2D. Have you seen that? Then same way, adding the constant to this, I'll have plus 3D. So we can see that in this particular, that one was to the nth term. The term we need to find is formula. The term we need to find is formula. But guys, note that this one was the first term, this one was the second term, and this was the third term. Have you seen that, guys? Including this as the fourth term in that order to the nth term. So what will we do to get this particular formula? So now, looking at it critically and thinking very well, we can see that this is multiplying by 1, this is multiplying by 2, this is multiplying by 3. And that means that it will continue in that order. The D will continue multiplying by the counting numbers in an increasing order. That is, this one was, let's say the um yes, the counting numbers. But let's bring it to whole numbers. I want to explain this. So 0 was multiplying by D here, right? And then 1 was multiplying by D, 2 was multiplying by D, 3 was multiplying by D, 4 was multiplying by D. Have you seen that, guys? In that order. But this isn't, you can't just say it is multiplying by a counting number. So you just, when you are asked to find a particular term, like its value, you just multiply by a number, a counting number, or a whole number. Nah, it is not so. So thinking alongside with these particular positions, first term, second term, third term, fourth term, what comes into your mind? This is 2 and the coefficient of D here is 1. This is 3, the coefficient of D here is 2. That is, the constant is 2. This is 4, the coefficient of the constant here is 3. That means that to every position, if you want the coefficient of the constant, you decrease the position by 1, you get the coefficient of the constant. Are you seeing that, guys? To every position, when you decrease that position by 1, you will get the coefficient of the constant. That we said the difference between two terms gives that constant for an AP. So have you seen that, guys? So what we will now do is that we come here. So this is the nth term. Finding for the nth term, we will have A, then plus, I told you earlier on, you decrease it 1 by 1, That will be the coefficient. So this is our coefficient now. So this our coefficient will now be multiplying by d. So this is our nth term. So we quickly say the nth term of an AP is a plus into bracket n minus 1 multiplying by d, where a is the first term n is the number of terms and d is what? The difference or the constant that I talked about. So this is what I mean, guys. Let's quickly verify whether that equation is true or not. So let's say this is our first term. We put the first term 2 here. Have you seen that, guys? Then we put 1 as our first term here. So 1 and then the difference is 2. D is 2. So we put 2 here. 1 minus 1 is 0 times 2. 0 plus 2, 2. Have you seen that it is correct? Let's move on. We can't say it is correct. So we test for additional 2 terms. So let's say this the second term. So we put first term 2 plus into bracket 2 minus 1 then times 2. So the 2 minus 1 will give us 1, then times the 2 we'll have 2, then plus the 2, 4. Is it not proven? It is proven. So we do that to the third term. We have 2 here, then we have 3 here. 3 minus 1, that will be 2. 2 times the difference, of course, we know is 2. So 2 times 2 is what? 4. 4 plus 2 is 6. And the 6 here is it. Have you seen that, guys? So let's move on. After knowing all this, let's solve questions. Let's solve questions. Let's solve questions. So they can tell you that put three numbers between 10 and 18. Between 10 and 18 to form an AP. So guys, how do we solve this? Put three numbers between 10 and 18 to form an AP. My guys are seeing this to be a daunting task. This isn't a daunting task, guys. This is just cool. Actually, guys. This is just cool. They have given you a cool job. In this question, what you don't know is that D, the difference, the constant. So let's say 10 between 10 and 18. I'm putting three numbers between 10 and 18. This is how I will do it to form an AP. So this even solves the question for you, because when you do this, you'll get a clue about how to solve it. So these are the three numbers that should be placed between 10 and 18 to get me the AP. But we know that for an AP, For an AP, the difference between two consecutive terms is a constant. So, how do we get this constant? Of course, we know our general term un to be equal to a plus into bracket m minus 1 multiplying by d. Have you seen that, guys? Then we move on to say, okay, since un is equals to this, and we know that we are placing three numbers between 10 and 18 to get an AP, that means that we'll be having 5 terms here. Have you seen that, guys? Including the 10 and 18 will be 5 terms. That means that the 18 is on the 5th position, and that is n is equals to 5. We've sorted out one variable like that. Now, let's sort the other ones out in order to be able to find d. How will we do so to them? We know that for n is equals to 5, our u of 5 is 18. That is, the term there is 18. Is it not true? It is true. Our term there is 18, simply as that. Then let's look at a. Let's get a. So a is the first term in this our equation. A denotes the first term. So which of these numbers is the first term? Is it those to be found or those which are already there, one of them? Yes, those which are already there, and it is the 10. The 10 is the first term. Of course, a will be equals to 10. Now let's move on. Substituting all this into the formula, we'll have 18 is equal to 10 plus into bracket 5 minus 1 bracket close multiplying by d, because we don't know d. Now we'll have 8 is equals to 4d. Guys, have you seen that? 18 minus 10, you have 8. Then 5 minus 1, we will have 4. So 4d. That means that d is equal to 2. Simply as that, guys. But we know that the difference between two consecutive terms is a constant. So now we don't know whether we are adding to get the next term or we are subtracting to get the preceding term. In order for you to know that, compare the first term to the last term. So looking at the 10 and the 18, which one is the greater? The last term, of course, which is 18, is the greater than the 10. That means that from 10, when we are moving to the preceding term, we need to add 2. So when you add 2 to 10, what will we get? We will get 12. When we add 2 to 12, what will we get? 14. Then when we add 2 to 14, what will we get? We will get 16 in that order. So when we add 2 to 16, see that we'll get 18. So this question is solved. I hope you've gotten how to solve this question. It is solved. You have provided them the AP like that. The three numbers are inserted and it of course forms an AP. The sequence of course forms an AP. So let's move on, guys. Let's not waste time. Let's move on. Let's move on. Okay, without wasting time and moving on, you can have a question like this. You can have a question like this, given that the 20th term of an AP is 16 and the 10th term is 8. Find the 5th term. Guys, you can be given a question like this. That one too, how do we solve it? How do we solve this kind of question? Good. So we say when n is equal to, that's the solution that I'm giving out. That's, we denote n as the number of, or the position of the term. So when n is equals to 20, of course our u of 20, that is the term itself, will be 16. Then we know that when n is equal to 10, of course our u of 10 is equals to 8. Have you seen that, guys? Then when n is equals to 5, we know our u of 5 will be question mark. We don't know that one. So guys, have you seen that? So now I'm going to teach you a simple trick for doing that one without finding d. If not, the other way around is to find d, and now from there, not only d, but finding d and a before you can find the 5th term. If in the question they indicate that find a, d, and the 5th term, then you need to use that method. Simply as that. But if they don't, and they go straight to say find u of 5 or the 5th term, my brother, in order to save time, you need to go by the method I'm to show you. We know that our general term u of n is equals to a plus into bracket m minus 1 bracket close multiplying by d. We all know this general term. Now for n is equals to 20, u of 20 will be 16. That means that I'll quickly do every substitution. So I'll have 16 is equal to 16 is equal to a 16 is equals to a plus 19d. Have you seen that, guys? A plus 19d. Then I'll do my substitution for 10 as well. So I'll have here to be 8 is equals to a plus, when you put 10 here, you have 9d. Have you seen that, guys? Have you seen that, guys? So now this is equation 1, equation 2. So what do? I subtract equation 2 from 1. So I will quickly get 8 is equals to 10d. Then I'll get d is equal to 0.8. Have you seen that, guys? So this is my d. D is equals to 0.8. Now, I will come to here in order to get a. I'll put d, which is 0.8, into equation 2. So I will have 8 is equals to a plus 9 times 0.8. Then I'll have a is equals to 8 minus 9 times 0.8 will give us what? 0.8. will give us what? 7.2 rather. Sorry, 7.2. This will give us 7.2. Then 8 minus 7.2, what will we get? We'll get 0.8. So this is our answer for A. Then we'll have A is equal to D, which is equals to 0.8 as our answers for A and D. Then, after knowing A and D, what will we do? We now find our U of 5, which says that U of 5 is equal to the first term, which is 0.8, plus n minus 1, which is 5 minus 1 times 0.8. Of course, we will have 0.8 plus 4 times 0.8. And this will give us 0.8 plus 3.4 times 8 is what? 4 times 8, 4 times 8. That is 4 point, no, 2.4 times 8, 3.2. Sorry, 3.2. So this will be 3.2. Then we'll have 4.0 as the answer. So U5 is 4.0. U5 is 4.0, and that is our final answer. But guys, the way I wanted to show you is here simply. It is here. It is here. Very simple. How did I get that way? The shortest way. You take this minus that, like we did here. We'll have 16 minus what? 8 is equal to 19d minus 9d. Have you seen that, guys? Then you take the equation that you want, that is U of 5 should be equals to A plus 4D. This is how it should have been. And we don't know 4, we don't know D, we don't know A. So what we will do is that we quickly take this minus that as well. So I'll have 8 minus 5, sorry, 8 minus U5 rather, is equals to 9D minus 4D. What will I get? I will get 5D. So this minus this, what will I get? This minus this, what will I get? I will get 8. Have you seen that, guys? I will get 8. This minus this, what will I get? I will get 10D. Have you seen that, guys? So I've had 10D here. I've had 8 here. Then this one, I've had 5D. I've had 8 minus U5 here. Have you seen that, guys? So this is my one equation. This is another equation. From the 4 equations, guys, so we are dividing equation 2 by 1 or 1 by 2. So let's divide 2 by 1. What will we get? 10d over 5d will be equals to 8 over 8 minus u5. Have you seen that, guys? This is what I was talking about. So the d will go with this d. This will go here too. So we'll have 8 over 8 minus u5 is equal to 2. Have you seen that, guys? So when you get this, simply you multiply this by this. So we'll have 8 is equal to 16 minus 2u5. Have you seen that, guys? So you take this here and take this that. We have 2u5 is equals to 16 minus 8. we have 2u5 is equals to 8. Then we'll have u5 when you divide both sides by 2 is equals to 4. So guys, this was the way I was showing you. So let's quickly drive that. Let's quickly drive that. Let's quickly drive that. Let's quickly drive that. So let's say you are having positions n is equals to x term, and that one is ux. N is equals to y term, and that one is uy. N is equals to z term, and that one is uz. Okay, you know these two, but you want to find this. How will you find it in an easier way, fastest way, in a faster way? So I'm here to show you. Okay, this is the position and this is the term. So we'll have pertaining to this formula, we will have u of x. Let's say the first term is a. We don't know it. But after all, this first term and the difference, let's say is d. We don't know the difference. But after all, I'm sure they will be gone. So we'll have ux to be equal to a plus into bracket x minus 1 bracket close, then multiplying by d. Have you seen that, guys? That's the difference. Then we'll have uy, this one, equals a plus into bracket y minus 1 multiplying by d. Have you seen that, guys? Then we'll also have uz to be equal to a plus into bracket z minus 1 multiplying by d. So we have obtained three equations now. That is equation 1, equation 2, equation 3. So guys, what we will do is that let's take equation 2 minus 1. Equation 2 minus 1 will give us uy minus ux. Have you seen that, guys, for this side? And this minus this will be what? 0. Have you seen that, guys? So this will be equal to this minus this. Don't be confused. So this minus this will be like this, whereby we can factor. So it will be like y minus 1 d minus x minus 1 d. So here you can factor d out, leaving it this way: y minus 1 minus into bracket x minus 1. Because the minus is affecting the whole bracket, you don't need to open it like this one. Then we'll have d outside. Have you seen how it will be like? Then this opening the bracket, you will have y minus 1 minus x plus, see that, plus 1, then multiplying by d. Have you seen that, guys? So this one will go with this one. Have you seen that, guys? Leaving y minus x into bracket d. Have you seen that, guys? So that means that when we come here, it will be left with y minus x into bracket d. Have you seen that? Have you seen that, guys? So it will be left with y minus x into bracket d. So let's move on, guys. Moving on, moving on, let's take equation this minus that. So we'll have uz minus ux is equal to, so guys, it will also look like, it will also look similar. Do that on your own and you will get like this. So this minus this will be 0, and then it will look similar like this: z minus x. Have you seen that, guys? Z minus x, following the same way that we did here, you get it like that: z minus x d. Have you seen that, guys? So we have obtained other equations, that is 4 and 5, from this 1, 2, 3. Have you seen that, guys? Now what we will do is that let's divide equation 5 by 4. So what we will do is that we divide 5 by 4. We'll have uz minus ux all over uy minus ux. Have you seen that, guys? Then this will be equal to, this will be equal to this will be equals to this divided by this. So when this is dividing by this, the d will go away with this. So we now have z minus x all over y minus x. So simply as this. So this is the equation that will give you the fastest answer to that. The fastest answer to that. You don't need to waste time. You just get a fast answer, Charlie. You don't need to waste any time. Now let's go back to solving our answer with our question again with this equation. I just solved it using this method, how we use the method to prove this one. I just solved it. So I think you didn't understand. Let's solve it using that this thing and you see. So we said for the, let's say for the 20th term was uz. uz was the 20th term and z is equals to 20. So like given that the 20th term of an AP is 16, so the 20th term is 16 rather. So that is, and z is the 20th term, that is the term 16 and 20. And then ux, let's say ux is the 10th term, which is 8. So we'll have x to be 10. Have you seen that, guys? X will be equals to 10. Then we say uy, we don't know. We don't know uy. Uy is the one that we are to find. But we know that it is the 5th term. We know that it is the 5th term. But it is the one that we are going to find. Have you seen that, guys? So it is the one that we are going to find. So what will we do now? We substitute all this into the equation and we'll get a simple. So we have uz, which is 16, minus ux, which is 8, all over uy, which we don't know, minus ux, which is 8, is equal to z, which is 20, minus x, which is 10, all over y, which is 5, minus minus x, which is 10. So guys, this is what we will get. So we'll now get 8 over uy minus 8. Have you seen that, guys? It's equals to, this will be 10 over minus 5. So guys, 10 over minus 5, we'll get 8 over uy minus 8 is equals to minus 2. Have you seen that, guys? Then we'll cross multiply. What will we get? This will be over 1. When we cross multiply, what will we get, guys? We will get 8 is equal to minus 2uy plus 16. Have you seen that, guys? So we take this 2uy across here. 2uy is equals to 16 minus 8. Have you seen that, guys? So 16 minus 8, of course, is 8. 2uy will be equals to that one, which shows that uy will be equal to, uy will be equals to what? 4, which is the answer we got as u5 here. So guys, have you seen the whole thing now? Have you seen the whole thing now? You need to be following my hand in order to get everything. So that is it. So there is one thing they call arithmetic mean. Arithmetic mean. The arithmetic mean is a number that actually divides. It's a number that divides a sequence into two. So that is the arithmetic mean. That number divides a sequence into two. It divides a sequence into two. So let's say we have two numbers, 2, and it makes it AP. What if it is, although like arithmetic is about AP. So let's say we have 2 and 4. 2 and 4. So that number should be dividing 2 and 4 and into 2 and also making it form an AP. So Which number do you think will be that? That it will form an AP and also divide 2 and 4 into 2. So we have 2, 3, 4. Is there any other number? No, it's only that one. So meaning 3 is the arithmetic mean. So how do we find arithmetic mean of two consecutive numbers? So let's say this is this is a number and they always form an AP. So this is a number, this is the arithmetic mean, they always form an AP, and this is another number. So how do we do about this? So how do we do about this? Now we know that the difference between two numbers is a constant in two consecutive numbers is a constant in an AP, but it should be taken in the right sense. That is, you can't take this minus this and you expect it to be constant as you take this minus this again. No, if you take this minus this, you should take this minus this in that order. Or if you take this minus this, you should take this minus this in that order. So what do we do now? We take this minus this. So what will we get? D. So let me just write these numbers as A, M, and what? B. Have you seen that? We are to derive the mean, the arithmetic mean. So when you take M minus A, it should be the same as when you take B minus M. Have you seen that, guys? But the arithmetic mean, I told you earlier on, that is the one that divides two numbers, like it separates them, and the difference between that one and any of the numbers is a constant. That is, it makes it those three, it adds up to those two numbers to form an AP. So you see that we will get this. Then rearranging, taking this here and that there, we'll have 2m is equals to a plus b. Then we'll have m is equals to a plus b all over 2. So this is the arithmetic mean formula. This is the arithmetic mean formula. Simply as this. So when you have 4 and 10, my brother, when they say find the arithmetic mean, fast, 4 times 10, 4 plus 10, you take the sum over 2, and this will yield you 7. This will give you 7. So 7 minus 4 should be 3. 10 minus 7, 3. See that the difference, or the constant difference between them, is constant, or there is a constant difference between them. So now let's move on. I hope I've shown you the various ways of solving the difficult questions. The questions that are now left are not difficult, and this. Let's move on to how to sum complex, how to sum sequences and AP. So this isn't actually part of the work. So how do we sum an AP? So we first said an AP is given by a first term and a constant difference is a constant number is added to each preceding term to give the preceding term. Oh, this pen, what's up? Dot 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 dot. So now, actually, Frederick Goss was the one who thought of this formula first. In fact, their teacher was a lottery man who wanted to cast like his lotto. So he went and sat down, was doing permutation and combination to get his lottery being done. So he decided to give them numbers from 1 to 100 to sum. So this guy developed this technique and he found the answer within a couple of minutes. So how did the guy do? So he said, let a sequence be like this. So the sequence is up to what? The third term. Have you seen that, guys? So we can let a sequence be like this. It's up to the fourth term rather, sorry, fourth term. So let a sequence be like this. Then let us reverse this particular sequence here. He said so. So we have a plus 3d here, a plus 2d, then we have a plus d here, then we have a here. Have you seen that, guys? Then we have dot 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 going. So he told himself that let's reverse this way. So now let's add them. The guy was really thinking. Said let's add them. So he added. So he added. So let's just bring the last terms. Let's leave the last terms, cry. Let's leave the last terms and do this after that. So he added this to this, and he had 2a plus 3d. Have you seen that? He added this to this is 2d. Added this to this. He had 2a plus 3d. This to this. 2a plus 3d. He added this to this. Had 2a plus 3d. So you see, adding this to this 2a plus 3d, this to this 2a plus 3d, this to this 2a plus 3d, this to this 2a plus 3d. See that, guys? But I first told you that in order to find this 3, you need to put m minus 1 there in order to find a 3. Same here, same here. Have you seen that, guys? So that is it. So after doing this, he realized that, hey, they have become the same numbers throughout. Then I don't even need to sum this because intelligence will tell you that when the numbers are the same and you want to find the sum of them, you need to multiply one of them by the number of times they occur. So this guy said they occur 4 times. Have you seen that? That's we only use the first 4 of the AP to do so. So they occur 4 times. So he quickly said then 2 plus 3d in bracket times 4. But this guy again told himself that, but I summed 2 sequences to get that. So what will I do now? I will have to divide by 2 in order to get the other sequence, only for one sequence. So the guy quickly divided by 2. So don't forget that this one is the number of tens. So that is n. And then this 2 only comes because there were 2 sequences. So replacing everything there, the 3, how was it calculated? It was calculated from n minus 1. So we have 2a plus into bracket n minus 1 bracket close multiplying by d. Have you seen that, guys? Then this is multiplying by that same number of tens all over 2. And this was the sum formula. See how the guy was brilliant? And that was the sum formula. So he went on and realized that, okay, this over this, then remove 1a here, bring 1a plus n minus b, a1, multiplied by d. Have you seen that, guys? So this particular expression here represents what? we've seen that earlier on. We saw that earlier on that it was UN, the general nth term. So he quickly replaced the general nth term there. So he said n over 2 into bracket a plus the general nth term. Simply as that. So if you know the first term and know the last term, you can find the sum of that AP. If you also know the first term alone and know the difference, and they give you that you should find to then a particular number of terms, you can find the sum. So this is actually how the sum was gotten. So guys, let's solve questions. So they can say find the sum of the first 5 terms of the AP. 2, 4, 6. So what will we do, guy? First 10 terms rather. Find the sum of the first 10 terms. So our n will be equals to what? 10. We are using this one like that. So n will be equals to 10. A will be equals to 2. This minus this, D will be equals to 2. And of course, when you put everything there, 10 over what? 2 multiplying by 2 times 2, that is this one. 2 times 2, then plus to bracket 10 minus 1 multiplying by D, which is 2, bracket close. You actually get 5 multiplying by into bracket 4 plus 18. This will give us 5 times 18. Let's add them, 22 times 5, which I will get 110. So that is it, 110, simply as that, and you are gone. Okay, when you are given the find the sum of the terms of a sequence whose first term is 10 and last term is 100, what will we do? Guys, what we will do is that we don't know n, so we will need to find n. So what we will do is that we say, and the common difference is 5. So we will say that um we will say 100, which is the last term, is equals to the first term plus into bracket m minus 1 times the difference. Have you seen that, guys? Then we will take this here, we'll have 90 is equals to 5n minus 5. Have you seen that, guys? Then taking the 5 here, we'll have 95 to be 95 is equals to 5n. Then n will be equals to 19. That's the 19th term. So we come here and put, then the sum to the 19th term is equals to 19 all over 2 multiplying by 10 plus 100. Have you seen that, guys? Simply as that. Then we'll have 19 over 2 times 110, which will be equals to 19 times 55. Then 19 times 55 will be 19 times 55 will be 1045. So we'll have it as 1045. So 1045 is our answer. Is our answer here. Have you seen that, guys? So these are simply as that. So they can tell you They can tell you that place, that of the sum equation of a sequence. Oh, we'll do that one later. So this is how we find them. So they can tell you that the sum is 100, first term is 10, last term is 100, common difference is 5. Last term is, let's say, 20, common difference is 5. Then find the nth term, like find n, simply as that. So you need to use those equations. So thank you. Next time I'll bring to you geometric progression, and then from there we will diagnose the topic into the deeper section. Thank you. Have a nice day. Don't forget to subscribe, like, and comment. I hope this video is now the best among the rest. Thank you.